Hello and welcome to all. Today we will discuss about one more question related to the motion in one dimension, in which a topic which we have discussed earlier, that motion under gravity. This question is related to motion under gravity. The question states that a stone thrown vertically upward and it takes 4 seconds to return to thrower. Then calculate initial velocity of a stone and the maximum height attained by the stone during its motion. And it is given that take g equal to 10 meter per second square. In this question, it is given that the total time is 4 second. This is the total time of motion of the object, and g is given, acceleration due to gravity is taken as 10 meter per second square. Then if you see the motion of the object, here is a stone which is thrown upward with initial velocity u, and as from the motion under gravity we know that if an object moves upward, here acceleration due to gravity is acted in downward direction and the direction of velocity is in upward direction. Therefore it causes decrease in motion. Here g is taken as negative acceleration, and after certain time the velocity of the object will be zero. That is, the final velocity of the object will be zero at this point. This is the point at which the final velocity of the object is zero, and it is at h height from the initial point. It is given that in question an object is thrown upward with velocity u and it reached its maximum height. Suppose this is the point A and this is the point B. Then it returned to again its normal position, that is in the level of thrower. Then there is two motion, one is from A to B and second is B to A, and here T is given for this both motion, from T for A to B and plus T for B to A. This total time is given as 4 seconds. Therefore during motion from A to B will be equal to B to A will be equal to 4 upon 2, which is equal to 2 seconds. Therefore 2 seconds is the time required for motion from A to B and as well as B to A. Now we have to concentrate on the question. The first part of the question is said that the initial velocity of the stone, it is to be find, and the maximum height attained by the stone. Then first part of the question is initial velocity of the stone. As from this diagram it is clear that the initial velocity is u, final velocity is v, and acceleration due to gravity is g, which is acted in the opposite direction of the initial velocity. Therefore, here acceleration is taken as minus g and initial velocity is u and t will be equal to 2 second. This is for t time required to motion of A to B, motion of stone from A to B. Then from the equation of motion we know that v equal to u plus at. Here a is positive, but in this case the a is negative, and the final velocity from this condition, the final velocity is 0. Then putting the value of a, u and t in this equation, u b equal to 0, u we have to find out. A is minus g and t is 2 second. Therefore u equal to g into 2. G is given that 10 meter per second square. 10 into 2, which is equal to 20 meter per second. Then the initial velocity, this is the initial velocity of the stone u, which is equal to 20 meter per second. And the second part of the question is to find the maximum height attained by the object during its motion. Here h will be the maximum height, which is obtained by the formula h equal to ut plus half at square. H we have to find out. Here u we have to find that u is 20 meter per second. U is 20 meter per second, which is find here, and a is again minus a is again minus g, which is equal to 10 meter per second square, and t is 2 second. Then now put all the values in this equation. We have to calculate the value h. 20 into t is 2, and here g will be in minus, therefore half into 10 into 2 square. This is 40 minus, this will be 5, it is 20. 2 square will be equal to 4. 4 into 5, 20, and this is will be 20. Then the maximum height is 20 meter. This is the maximum height. Then the initial velocity is 20 meter per second, and maximum height h will be 20 meter. This is the answer. Now this is all about motion in one dimension with the equation of motion and representation of motion in one dimension with the help of graph with some numericals. If you have any doubts, you can ask me. Now we will start the next chapter, which is known as law of motion. The name of the chapter is law of motion, in which first of all we will discuss about the term force. What is force? Force basically it is a physical cause which changes or try to change either the size or shape or the state of rest or motion of the object or body. We have to understand the definition of force with some examples. Here, assume that an object A is rest on a horizontal plane, and if force is applied on it, it changes its position from A to B. It reached to point B. This represents that due to force, the object changes its position from one point to another point. And if you see the spring, this is a spring which may be stressed. This is the initial length of L, and if force is applied in outward direction on the both ends, the length of the spring will increase. It means that the size of the spring is changed. If you want to compress the spring, then the size of the spring gets reduced. This represent the force is also responsible to change the size of the object. There are some examples in our daily life. Various examples are present. Then we can say that force is a physical cause, or it is an external agent which is responsible for change or try to change, in both conditions, change or try to change the size or shape or the state of rest or motion of the body. If you want to push the wall, here is, this is a wall. If this is a wall and we want to push it, then there is no change in its state of rest or its shape or size, but here force is applied on it. Then we can say that the force is responsible for either change or try to change the position, shape or size of the object. Then we have to understand the types of forces according to nature of the acting force. The classification of force can be, the classification can be done in different ways. Here is the one method of classification of force is according to nature of the force is acting. On this basis, it is of two types. First one is contact force and second one is non-contact force. Contact force are those forces in which the force is acting between the bodies which are in physical contact. That is, if we want to push a wall, we applying a force on it. Here, first of all, we touch the wall and with the help of our hand, we applying force on the wall. This is example of contact force. Another example of contact force is if an object is placed on the horizontal surface and we push the object on the surface, and if the surface is rough, then there is always a opposing force act in the direction of opposite direction of the tendency of motion of the object. If due to this force, external force, the object having tendency to moves in rightward direction, then a resistive force is acted between the surface of these two, the object A and this horizontal surface. A resistive force is acting in leftward direction, which is in opposite to the motion of the object. This force is known as frictional force. This is frictional friction force, and it acted in opposite to the motion of the object. This is also a contact force, and it acts between the surface of this two bodies, body A and the body at which this object is in rest condition. Another example of contact force. If an object is placed on the surface, this object exert a force equal to its weight, that is mg, in downward direction, and the surface on which this object is in rest, this surface exert a reaction force in opposite direction. The reaction force here, the reaction force is contact force, and this force is a non-contact force. If an object is attached with an string, this is the string, the object exert a downward force equal to its weight if the mass of the object is m, and in string there is always a tension applied in opposite to the weight of the object, or tension is acted away from the object. It will act in away direction from the object. This is a stretched spring. Then in spring there is always tendency to return to its original position, and force is applied in this direction. This is the direction of force acted in the spring in a stressed condition. A stressed spring. But if the spring is compressed, if the spring is compressed, then the direction of force will be reversed. This is then the direction of force is reversed of a stressed spring. This is the compressed spring, in which there is always a tendency to regain its neutral position of the spring. If the spring is stressed, then the tendency of the spring is to get back to its original position, and force is applied in this direction. If spring is stretched, then there is also a tendency to return its original position, and direction of force is like this, to return its original position. Here is to return its original position by expand itself. These are the some examples related to contact forces. In next chapter we will discuss some more examples related to contact forces, and understand about the non-contact forces with their examples and characteristics of contact forces and non-contact forces. Thank you.